Hello everyone, and welcome to this webinar on meshing within Oasys PRIMER. My name's Rory, and I'm going to be taking you through this meshing webinar today. Just a point to note, you are all muted at the moment, and if you have any questions throughout the webinar, you can type them into the question box. At the end, I'll go through them and hopefully answer them. All of our webinars are recorded, and you can view them on the website afterwards as well. This one's going to be uploaded too. Today, I'm going to be demonstrating the meshing capabilities of Primer. So first, just a quick overview of what we'll be looking at in this webinar. I'll start by talking about meshing in Primer and the mesh tools built in. Then we'll look at mesh creation and the options for creating different meshes, followed by some demonstrations. Next, I'll talk about mesh review, how you can check your element quality, improve it, and I'll have some demonstrations of them. And then finally, I'll talk about mesh manipulation and the options available, such as removing or adding holes, swages, splitting, and even remeshing. And I'll have some demonstrations of them. And then at the end, I'll try and answer your questions. So, meshing in Primer. Oasys Primer has many useful tools for creating, modifying, and reviewing shell, solid, and beam element meshes. In this webinar, we'll mainly focus on shell meshes. You can access the Mesh Tools options at the top of the control pane within Primer. Many of the options in the Mesh Tools pane have multiple sub-options, which you can see by clicking on them and are indicated by the drop-down arrows. We're now going to look in more detail at the Mesh Tools specifically for mesh creation. I've listed them here in this table, and you can see that most of them are applicable to shells, some to solids, and some to beams as well. I'll go through each of these in the following demonstrations. So first of all, I'm going to show you some mesh creation tools. So I'm in Primer 17 here. I'm using the new dark mode. And firstly, I'll select Mesh Tools in the top control pane. This gives me access to all the meshing tools I might want to use. So I'll click on Mesh here and we'll see a drop down appears, and I'll just select the first one, Area. I'm going to briefly go through all the mesh creation options here. So we're presented with another window and it says Mesh Area from Corners. We can see that we can change some of these parameters, and this gives us access to other mesh creation options, and we can change the inputs from quad to triangular. So I'm first going to give it a latent part 1, so it just appears in blue, and I need to create some nodes for the shells to be made on. So I'm just going to quickly create some nodes, 0, 0, 0, and I'll just go around clockwise, keeping the order, and let's set X to 10, node 3, create X and Y to 10, and lastly Y to 10 here. So if I zoom out, I can see all 4 of those nodes that I've just created, and I can decide how many shells are created in each direction. So I'm going to have 10 shells between node 1 and 2 and 5 between 1 and 4. When I click apply, you'll see that a red square appears, and when I press Y a couple of times, we'll see that the mesh appears. I can keep that, or I could undo that by just clicking on the undo button here. So what happens if I click on the triangular option? Well, the triangular option, now I only have 3 nodes to pick from. I'll just leave them as they were, and one option of just deciding how many go along the dimensions. So when I now assign a part and click apply, we can see that a triangular mesh has been created. Okay, so I'll just undo that. And next I'm going to show you the block and box options. So I can click the drop down arrow here, block and box. This also would be accessible from the shapes, block and box. It just takes you to the same place. And we see we have 2 options, solids and shells. So this is like making a cube, either with a shell outer or with solids filling up the whole box. So I'm going to first just keep it as solids, and I'm going to give it part 2, and I can just define a center node. So I could either use a coordinate option or pick a node. Since I've got one here already, I'll just pick that. Turns out that's 0, 0, 0 as defined. I'll leave these options as they are. So the sides are 10, 10, 10, and the number of solids in those dimensions, or I could specify the size, in which case it tries to fit as many of them as it can, and it does a division based on the dimension. So if I said 10 here, and then let's go for 5 here, and what about 8 here? And then we apply, and we see that centered on that node that I picked, we've created a cube. The same thing would happen if it was shell selected, however, it would be the coating. So how about I just do that quickly, give part 3, change this to shells, and let's make this a much smaller cube, 1, 1, and how about Z dimension is 2. And then I need to change the node, so I'll just pick a node, how about this one up here, click apply, and we see that our shell box has been made. Next, we're going to look at coating. So coating is a way in which you can make shells based on the surface of a solid object. So here I have a green cube made of solid elements, and I'm going to coat this in various ways. You can access the coating options under the mesh tools and clicking on coat. Here you'll see a coating pane appear. So first of all, I'm going to just coat some external faces. So click external faces, and I'll give it a dummy part for the shells to go in. Note you can also create segments if you like. External faces, and I'll just do it as a whole part. So I'll click on this one part, and I'll go apply. That's coated the entire green box with shells. Now notice that there's this stippling effect, and this is actually, if I dismiss this, control down here, draw coating as, and the default is 8x8 for me, and so if I set it solid color, it would change that to look like normal shells. Now you can also revert back to the normal effect by closing the coating pane. It's like saying you've accepted the coating, and then you'll see that those shells appear. Now, if I was to say blank some elements and then look inside, and maybe I'll blank the part, the green part, you can see that it's made a shell around that green box. So unblank everything, and I'll just click undo at the top, and that's back to the green box. So next, I'm now going to look at exposed faces. And for this one, I'm just going to select some specific elements. Again, just assigning a part here. And I'm going to select some solids. So I'll just click on some solids, and we'll see what effect this has. So when I click apply, you could see for a split second that it made the shells around the whole of those elements selected. So if I just blank this part here and close this down, you can see that those shells are made. Now note that when I blank those elements, there's no internal shells made, and that is the difference between coat options, exposed faces and all faces. So if I just come back here and I go coat, and for this one I'm just going to change now my stippling to solid color. I'm going to select some shells, and I'm going to make a new part 5, and I'm just going to select some elements, so solid elements, and I'll just select one here and then 2 in a row here, and you'll see the difference. So when I click apply, I can then blank that part, and then you'll see that the internal faces have also been made here. So if I blank this elements just to show that more clearly, you'll see that an internal face has been made. So if I change the transparency of those to opaque and just close down the coating, then you'll see that those internal faces were made, and they weren't made in the other option when we had exposed faces. So the way to think about this is when you're using these options, it's as if the elements that you select are on their own, everything else is blanked, and then you coat around all the faces for exposed face. For all faces, it's the internal ones as well. Next, I'm now going to show you the face options. So bring back here, and this is a way you can coat an entire plane. So I'll select face, and then if I go into propagate, and I can leave that as 20 degrees here, I can then coat an entire face. Now you can leave this visible unblanked only on or off depending on what you want. In this case, if I blank some of these elements here and then go to coating options, if I use visible unblanked only, so first of all I'll leave that disabled and I'll create part 6, and then I will select an element here, and you'll notice that it actually selected and propagated to those faces that were blanked as well. So if I sketch new shells, you can see that that plane would be created. If, however, I change to visible unblanked only and I restart that process, so restart, reassign part 6 and select a face here. Now I'll sketch the new shells. You see that it's just the face that was visible. So I can go ahead, I can apply, I can see that it's only that face. So that is a brief overview of the coating options available to you. Next, we're going to look at how to make cylinders and tubes out of shells. So mesh tools, click on shapes and then cylinder. And we can see that we have two options, tube and cylinder. So I'm just going to leave that as tube to start with. We need to define a part for the shells to go into. So part 6, and then we can define an axis origin. So this is where the tube will start. So pick one, might as well pick this node here. And then axis point. Now this could be a node, coordinate, or one of the global directions. And really the important thing to note about this is that if you pick a node or coordinate, then that is a node that will lie on the axis of the cylinder or tube. So in this case, I'm just going to pick a node down here. And how about I make this quite long, let's say 50 long, and I'll give it a radius of 2 meters, and number of shells, we'll leave that as it is. So I'll click apply to make the tube, and we'll see that we've got our tube created. And importantly, if we look down here, we'll see that that node that we picked as our axis point lies in the center of that cylinder we've created. And yes, the difference between a tube and a cylinder is just that the cylinder has closed ends. So I could just change the cylinder, click apply. We'll see that now we've made a cylinder with these closed ends. So let's close down the meshing options for cylinders with C. And for this next part, I'm going to just have the cube available. So only on that, and center it with A, and 2 to have a ZY view. So we're now going to look at the extrude options. So if we go into mesh and click on extrude, then we can see we need to select some nodes, or we could select some shells. If we select nodes, then we can either extrude to shells or beams. And if we select shells, then we can extrude to solids or to thick shells. So in this case, I'm just going to select some nodes and I'm going to extrude to some shells. So I'm just going to select part 7, and now I need to select some nodes. So I'll click on select, and we have this part here. So I'm just going to select some of these nodes along the side, just there, click apply. So I've selected those 6 nodes. Now I need to pick a direction. So in this case, I'll just go in the X direction, and I'll define number of shells. So pick 5 shells, and we'll travel a distance of 5. So clicking apply, we can now see that we have extruded that line of nodes to make new shells. You could also do the same process but change to beams, or you could extrude some shells to solids. So for this next part, we're going to look at geometries, and I've just opened up a new keyword file with some geometry data in it, and I'm going to show you how you can mesh these surfaces. So first of all, you go to your mesh tools, and in this time you click on the mesh option and go to geometry. And here you'll see all these geometry surfaces displayed, so you can see them being highlighted as I go down the list. And what I'm going to do is I'm going to mesh the surface and show you one of the differences and the powerful things that Primer can do, which has been available in the last few versions. So the first thing we're going to do is we're going to select the element size, make this 500. Now these surfaces are actually from buildings, so that's why we're using 500. It's a larger scale. Otherwise the elements would be too small. And then I'm just going to give it a part for the shells to be created in. Leave that as 45 degrees, and I'm going to select all surfaces, click apply. In this case, you can see a faint blue line around the outside, and the internal edges and vertices are in grey. So the entire surface between these lines will be meshed using these properties here. And if I select on some of these lines or the vertices, then they will be preserved. So in this case, I'm just going to select those 3 lines, click apply, and we'll see that the mesh is preserved along those lines. I could also just select a subset of the surfaces. So just pick a couple of them, and I could click apply and then select any of the edges that we would like to be retained. So when I click Shift and Control at the same time, you see these highlighted more easily. Then clicking apply, and we'll now see the mesh has appeared. If I click confirm, then it actually makes it. And now if I go to entity options and I turn off the geometry so I can just see the mesh, click Y, you'll see that the mesh has been created. So we're now back in our other primer window, and I've blanked all the parts, and I'm going to show you the hemisphere and sphere options. So if I go to shapes and click on hemisphere, and I'll give it a new part, part 8, and we see we have options available to us, so we could change the hemisphere to sphere option in the drop down list. It's going to create these with shells. So first of all, we need to select a central node, or we could create a coordinate. So I'm just going to leave it as 0, 0, 0, and then a point of normal. So in this case, I'm just going to select pointing up. So a Z equals 1. Then a radius of our hemisphere and the number of shells along the circumference. So I'm just going to go for 64, and radius, we'll leave that as 2, and then we'll click apply, and we'll see that our hemisphere is created, and we'll see that it is aligned so that it is pointing, the cut of the hemisphere is along the Z direction. So if I click undo there, and I could change the option to a sphere, same again. Now I don't need the point of normal, and I could just give it a part, apply, and now a whole sphere is created. This is just the outside surface, so I can blank some entities, and there we can see the shell of our sphere. So next we're going to look at the line options. So you can go to the drop down and select line, or you could go to shapes and select line. Now line is for creating a line of beam elements. So first of all, you want to decide how many beams you want, give them a part. So we'll just go to part 10, and we'll have 10 beam elements here. And then you can either select coordinates or nodes. So in this case, I'll just go 0, 0, 0, and 0, 0, 10. So we're going to make 1 meter long elements each, and then we can choose an orientation vector for the beam elements that are made. So in this case, I'm just going to set it along the y-axis. Once I've done that, I can click apply. You can see the beam elements are made. So if I press 2 to go to the ZY view, you can see they're going up in the Z direction. At this point, my beams don't have any section properties, so I could go into the part and give them properties if I wanted. So just give them a beam part, thickness 1, and a thickness 1 here as well. And I'll make them, leave it rectangular, create, and just give it a part as well. So we'll create a null part. update. Okay, so you can see that those beams were made. Next, we're going to look at offset options. So we'll click on the drop down here, go to offset. You could also access this through the mesh option in the mesh tools pane and by clicking on offset here, achieves the same thing. And for this, you can either do shells or solids. So we'll just do some shells. And for this, we will want some shells to offset. So we'll unblank a part made of shells. So this is one we used previously to coat. And then we can go back to our meshing, offset, and we'll offset those as a copy. So we need to give it a new part. And then we will give them a distance. So let's give them a distance of 1, and these will offset in the normal direction. So we'll click select, and we'll go select these and apply. We'll see that they've offset. If I click M and measure, those have offset that 1 that I just specified. If, however, I unchecked offset copy, so I'll just undo this by clicking undo there. Uncheck offset copy, we don't need a part ID now. And what it will do is it will offset those shells I've selected. So you'll see it elongates them there. So that's what the offset tool does. It can be very useful if you want to move some shells or create a copy of them, which is a projection of them along the normals. So next I'm going to show you the plate option. So drop down here and select plate. You could also reach this going to shapes and then go to plate, drop down there. So we got a part defined, and we can select where the center of the plate is defined. So 0, 0, 0, and then an X and Y length that leaves us 2, and I'll this time use element size. So in this case, I'll just go for 0.2 so that we have 10 elements in that direction. And this case, I'll go for 0.7, which isn't a multiple, and I'll show you what that does. So when I click apply, it creates a plate here. I'll just blank these elements and show you the plate. So if I press M on the measure tool, then we can measure and we can see that it isn't actually 0.7, but it's the closest multiple of the distance that we defined. So the distance is fixed and the size is a bit more flexible in this case. But that's the plate, so it can be used for making an entire plane of shells. Next, I'm going to show you the ruled option. So you can access this by clicking ruled or under the mesh tab, ruled. This is useful if you have some nodes already existing and you want to create a mesh between them. So you can see it says create shells between 2 lines of nodes. So first of all, I'm going to assign a new part 12, and then I'm going to select some nodes. So there are multiple ways we can select nodes. So clicking select, and then we can either have edge nodes or shortest path, or just manually clicking them each like this. Middle mouse button undoes those selections. If I click edge nodes and then select here and here, it will fill in the gap. Middle mouse button to undo them, and I can click restart if I need to start again, or using shortest path. So I can click on a couple and it sort of defines the shortest path there. In this case, I'm just going to use the edge node option. So middle mouse button to undo that, select edge nodes. In this case, I'll go for all of those ones on that side. And here, I'm just going to go for a subset of those nodes. Number of shells between, I'll leave them as 5. And then I'll use a structured mesh to start with. So when I click preview mesh, we can see what sort of mesh is going to be created. So you can see it's creating these triangular elements here because you've got to transition from more shells on one side to the other. If I used a free mesh and then preview, we can see it creates a different effect. So it's regular along here, but it changes the mesh to fanning out in the top. So sometimes you might want an effect like this, and sometimes you might want to use the structured mesh. So make sure that the element size makes sense. So in this case, I'm just going to do number of shells, 5, and preview mesh as we had before. Click apply and it makes that mesh. If I blank that part behind the scenes, then we'll see that mesh that we've just made, the ruled mesh. Lastly, we're going to look at the Tet Mesher. So for this, we need some shells which enclose a volume. They can either be triangulated or quads, in which case you need to use the auto split quads option. So first of all, I'm going to go to shapes and box, and I'm just going to create a box of shells. So I'll use these options 1, 1, 1, 12, 8, 4 on the sides, apply, and I've created the box of shells. Next, back to the Tet Mesher, I can add some shells. So I'll go and select all of these shells, apply, and I need a part for the solids. So 21, apply. So it just takes a little bit of time to complete, and then you can see that we have made our tetrahedral mesh out of the solids. Next, we're going to look at reviewing meshes. Primer has powerful built-in tools to help you check your element quality. You can check things such as element length or aspect ratio, warpage, skew, and you can visualize them as contour plots. You can also contour failed elements and see easily and quickly where modifications might need to be made. The quality tool also enables you to improve your mesh quality. It gives you the option of dragging nodes around, either manually or automatically optimizing based on your optimizing criteria. I'll show you some examples of these in the following demonstrations. You can also get a really good summary of your element quality and those elements that are failing from within the checking options. Simply click on check and then go to element quality, and a quality tree will pop up where you can interrogate your model. So I've got a Hyundai Accord model open, and in this part of the webinar, I'm going to show you some of the review tools within Primer. So first of all, you go to your Mesh Tools options and then click on Quality. Give it some time to open. Depending how big your model is, this will take longer or shorter. You'll see that some quality imperfection contours have opened. And most of the model is blue, which really means that most of the elements are passing our quality criteria. If we want to see what these criteria are, then we can click on Settings and go to Element Quality Options, and then see those here. So in this case, we can see that we can set some criteria on lengths for shells, solids, and T-shells, aspect ratio, warpage, skew, the angle of triads, quads, Jacobians, taper, and collapse. These are things you might be familiar with if you've used other meshing software. You can also run a check on the time step of the elements and some added mass. So I'll just click the time step one. And then there are these weighting factors, and weighting factors are used in the calculation of the quality imperfection check and in the failure criterion. So if I dismiss this now and show you some of the options in the element quality settings. So we could first of all look at length, give it some time to compute, and it's now showing me that we have elements that are 0.06 to 22.25. And we can go to aspect ratio, same again. And in this case, I'm going to click on the contour, left click on the biggest one and press A to auto center. And we see that we have this element in our aspect ratio with an aspect ratio of 107.22. So this element is failing the criteria, and we might want to do something about that. To return back to the contour, you then click with the middle mouse button and all of the contours are returned, so A to auto center. I've turned the mesh on here with a Y. I'm going to turn that off just for clarity. And for the rest of this, I'm just going to show you the element quality settings on the roof. So to blank the roof, I'm going to press Q, left click, and then R to reverse, and now I've got just the roof showing. I'm also just going to lock the view so that when I press U to unblank, it's only these elements in in this part that are showing. So now I'll show you some warpage options: skew, minimum angle, maximum angle, Jacobian, max taper, tetra collapse. We don't have any of them. And then the quality and perfection as we had to start with. Now note that for the quality and perfection and failure criteria, the weightings are also displayed here. And for the failure criteria, we can click on that. We have the option of selecting and deselecting some of these options. So in this case, we can see our failure criteria, and 12,630 of the elements showing are okay, so they're passing our criterion. However, we have 1,949 failing on length, and then some failing on angle, and the rest failing on time step criteria. Now, it's important to note that failure criteria prioritizes those with the highest weighting and shows them. So it's showing criteria for one, but it's possible for an element to fail on multiple criteria. So if we want to look at that, we could tweak the weightings, or I could disable length. We'll see that length goes to 0, and now some of these other ones. So the Jacobian has failed here. So if I go and have a look at Jacobian and zoom in with Z, I'll zoom here and I'll see this corner. Turn Y on to make it clearer. And we can see that some of these are failing the Jacobian criterion. Okay, so then we also have some options to set our minimum and maximum values of our contour bands, and then to change how these are shown. And you can also, down the bottom here, toggle on and off solids, thick shells, and shells. So if you were looking at multiple types of elements, I could disable them. In this case, it's only shells. So all of these returns all of those back to where they were. Okay, so that's a quick look at the element quality plotting. Now, I'm just going to update this and then close. I'm going to close this for a second as well. I'm going to show you another way you could access some of these options. So you can also contour using the drop-down options in the control pane. And we can see we can look at things like time steps, or we could even plot shell normals. So in this case, we see away and towards, so they're all aligned. Or we can look at our element quality options. So we have these options as we've seen previously. So minimum length, aspect ratio, warpage, skew. You can see the Jacobian one set because that was the last one we were on. And this is another way of accessing those options. You can also access the element quality options by going into the checking pane. Check, so if you're familiar with Primer, you'll know that you can check the model here, and also after you've run an analysis, you can read in the results here, but there's an element quality check. So if you click on that, you can get a quick summary of your element quality checks. So here we can see our solids are failing time steps and shells, and you can tweak these options around. And you can also click on the options here, and this is the same as if you went through the meshing quality and then click through to the quality options. And so here you could play around, tweak those numbers, and you can also check things like report duplicate elements. So this is very useful if you've done some copying and translating, and you might be concerned that you've got some duplicate elements in your model. So you could turn that on and it will run a check on duplicates as well. Okay, so I'm going to go into the quality options, and it's going to open up the drag node. Now, it's important to note that this actually is available also from the node options. So if you clicked in node here, you would see the node drag, or if you click node here, they actually achieve the same thing. So you might have noticed that we've got node, beam, shell, solids, and T-shells. This is just a quick access to those element options rather than having to click drop down, for example, and find your shells. And then you see that there's a drag option here, and that's the same as this drag node pane that appears. So this drag node pane is used to adjust and modify the mesh to improve its quality. And if I click on quality and settings, then I can change, just as I've had, what options I want. So in this case, I'm going to go to quality and perfection, and that's a way of sort of keeping track of all of your parameters and trying to get the best match of them. I'll update and then I'll close that now. And I'm going to focus on this corner here. So as it is, the drag node allows me just to click on some nodes and move them around. So I can zoom in, I'll click down left mouse button, and I can move this around. You can see the colors changing live. And so I might want to position that node so that I got some good color distribution between them, essentially trying to get closer to 0, so I'm improving my quality. So I've clicked there, release, and then I might tweak this node and move it around. So you get some good control here. You can also change what happens for free nodes. So for example, if I pick a node on the edge here, I can move it along, but I can't move it out of the line because it's a free edge, so it's respecting that edge. The same applies to a corner node. So if I picked this corner node here, it's not going to do anything. In fact, it will actually tell me an error, and it says increase the break angle or choose ignore free edges. So that's that option there. But I want to preserve the overall shape here, so I'll leave that the same. So the next option is if I click on optimize, and this is a way of it trying to automatically optimize for me. So it goes through some iterations and tries to improve the quality of all of the elements that are associated with either the node or the shells that I select. So in single node option, I can just click on this one node, give it a sec, and it's optimized. And it's decided that that's the best position for that node. I could do it again, and it will optimize it around. I could also click on multi-node options, and in this case, I'll select a group of shells, or I could even use the feature options and select an entire plane of them by just left clicking. But note, this will take a lot longer to run. So I'm just going to undo that and add some more shells. So I'll just click here. Okay, once I'm happy with my selection, I'll click Apply Optimization, and you'll see that it was optimized. If for whatever reason it's taking too long to optimize, you can always stop the process using the stop option down the bottom here. But that's a quick overview of the review options within Primer and ways in which you can optimize manually and automatically using these single and multi-node options here and the drag node tool. And finally, we're going to look at the mesh manipulation tools within Oasys Primer. There are various mesh manipulation options available to you within Oasys Primer. You can see them here. We've got Detach, and this is applicable to shells, solids, and beams. Combine, Orient, Remesh, Hole, Swages, Fixed Transitions, Split, Warp to Triad, and as usual, scripts or manual manipulation. All of these are applicable to shells, and you can see some of them to solids and beams as well. So we're back in the Honda Accord model looking at the roof of the car, and in this section I'm going to show you some of the mesh manipulation tools within Oasys Primer. So the first one we're going to look at is in the Mesh Tools option, and it's the Detach option. And to show you how this works, I'm also going to show you another modification tool, which is the Orient tool. Now, the Orient tool is actually generic, so it's for moving, translating, rotating parts and entities within Primer. But since meshes are made up of nodes and elements, we can actually modify our meshes using these options. So for example, I could pick a node and then I could translate it vertically and apply, and we'll see the effect that makes. And I could undo that and return it back to normal. So Orient allows us to give fine-grained control to the nodes and to the elements in the model. So what I'm first going to do is I'm going to select some shells, and then I'm going to translate them all just to, for clarity, 5 vertically. So we can see that it's distorted all of the neighboring elements. That's because those nodes are shared there. Now if I go to the, I'll accept this, and if I go to the mesh tool options and I go to detach, and then I select the shells, so shell and the ones that I had previously, there's 4. I can then detach, click apply, and it's going to detach them from all of the nodes that they were attached to. Then go back to Orient, and those shells are already selected. You can see them highlighted, and I'm now going to undo that, so I'm just going to change the Z displacement to negative. And what we now see is that it's detached those shells and the rest of the nodes didn't come with them. So that's the detach option. Note when you do some of these operations, those can't be undone. Okay, now I'm going to show you the warped triad option. So if I now change the view to shaded, you can see that some of these are warped and distorted. So I can fix that by selecting them and applying, and it will split that into two triads. So that's a way of fixing a warped element. You can see I'll do it again on this corner, apply, and it's created a split on that element there. You can also split elements using the split tool, and in this case you can actually split beams, shells and solids. With line is only for shells, so I'm going to click the shell option, and if we look at the drop down list here, you can also see the split options here as well as the detach option and combine, which we'll look at next. So the split option here allows you to, as the name suggests, split elements up into more elements. So I've clicked on that element and it split it up into 4 there. This is because I've got the single options set. If I set multiple, then I select those shells first of all. And then once I select apply, they'll be split. Now I can also change the way that the splitting occurs by selecting this drop down list. So you can see you can split into squares, triads, into 2 triangles or 3 or 4 triangles. You can split it on the diagonal, you can split into 3 by 3. Next I'm going to show you how to split with line. So click on split with line here, and I'm going to change it back to contouring of element quality just because it's easier to see. So select from shells, so I'll select these ones here, get to a nice view, and you draw a line screw space. So you click draw a line here, and then click the first point, and you can draw your line, click apply, and it's going to split along that line. So you see how it's split just those elements that were selected that also had a line over them. Now we're going to look at combining shells. So you can either access that through the drop-down list, click some combine shells, or you can actually find this from the shell element options. So click on shell here, you can see split/combine. It's also worth noting that there's also options to align the normals so that they're all pointing in the same direction, for example. So I'll click split combine and then go to the combine options here. And in this case, I'm just going to combine some quads. So I'll select them and then click apply, and it will combine all of them into one element. So now we're going to look at fixing some of these transitions. So in the mesh tools option, we have fix transition, and we can select some shells and it will fix those transitions so that all of the nodes are matched up and you don't have shells terminating against the edge of another shell. So we'll click here again and fix that transition, and it changes the mesh to make it work. Next, I'm going to show you how the holes tool works. So for this, I've opened up a model of a B post, and I'm going to go to the mesh tools and then click on hole. And in this case, I'm going to remove holes. So you can see this B post has some holes in it, and we're going to remove some of those holes. So first of all, we'll get a good view of the model, and I'll select multiple to get rid of lots of those holes. And then I'm going to select the max hole size that it's going to be removing. So I'll set this to 50. I'll leave the element size as 5. And then I'm going to select the part, so this part here, apply, and then click apply. But before I do that, you can see that it's actually highlighted the holes that it's going to be remeshing, the blue outline. So if I tweak this number, I made it smaller, say 20, you see some of those holes disappear. If I made it 100, then all of the holes are found. I'm just going to leave that as 50, and then I'm going to press apply. Give it a sec, and now we can see that it's given me a proposed remeshing area for those holes. I could tweak the element size here, maybe make it 7, and let it remesh. And then when I'm happy with it, I'll just click confirm. And it's filling in those holes. Pressing Y twice, I can now see the mesh. And now I might want to do some additional tweaking. So I could remesh this. So I'm just going to look at the top of the model, and we'll zoom in to the top. And then I'm going to click on remesh and area. And I'm going to add some shells. So I'll add some shells in this area. Click apply. And we see that the free edges are highlighted in blue and the internal boundaries are in red. I can now add some constraints to this mesh before I actually remesh. So I'm going to change the element size to 5, and I'm going to leave this feature limit at 20 for now and fixed point angle to 45. So first of all, I can select node, and here I can select any existing nodes, and they are going to be preserved in the new mesh. If I right click, I can undo and remove those nodes I've added. Now I can also add nodes not just on nodes, but on the lines between them, so the boundaries of shells. Or if I want to go for completely free, I can click anywhere and it will just put the nodes there. So right click to remove. I'll remove that one now. So I can also select feature lines, and this can be single feature, or I can choose to lock this and unlock this. So if I click on a feature line, it will propagate that for as long as the feature line limit is. If I select single, then it's just going to select a single line. So like an edge boundary of shells. So once I'm happy with my constraints, I might select a few more. I'll leave that one out, a few more down here. I click apply, and then before I actually mesh, I can tweak these numbers of elements on the boundaries. So left clicking increases, that's 25, right clicking decreases, that's 20. So I'm going to take these down to 16 and 16, and on this side I'll make it 16 as well. Then here I'll leave those all at 2 and 2, and I'm going to click apply. Now we can see the remesh has been achieved. If I'm not happy with this, I can reject it and redo the options, or I can select confirm to lock in my new mesh. Finally, I'm going to show you how to add swages to your shell meshes. So click on Mesh Tools and go to the Swages option, and you'll see various inputs are available to you. So I'm going to add a swage to this red part. So Z to zoom in to the area. And then first of all, I'm going to set my swage height. So I'm going to make that -8. And I'm also going to change the pitch to 6 here. And then I need to pick some points. So I'm going to pick a point here. And when I pick them, the swage will be added, but it's not applied until I click apply here. I can keep clicking and add a swage. It's continuous, so I can go all the way around here. And then I can tweak some of these inputs and see the effects live. So I change the angle here. I could change the end type, so I can make it flat-ended. Or I could change the corners. And when I'm happy with it, so I might make the top width slightly narrower and the bottom width also a bit narrower. When I'm happy with it, I click apply, and then you can see the swage has been made. So that's how you create swages. You can also undo them if you want to go back and restart the process. So that's the end of the meshing webinar. I hope you found it useful, and if you've got any questions, please feel free to ask them and I'll do my best to answer them.